Okay, so in this problem we've got a rigid tank. It's got 5 pounds of saturated water at 260 degrees Fahrenheit with 60% quality. I then add heat to it until it gets up to 320, and it says, hey, what's the final pressure? Okay, so here's the thing. Because it's a rigid tank, okay, the volume has to remain constant. So what I'll start by doing is find this volume, okay, using what I know about the initial state. Okay, so I know that T1 equals 260 degrees Fahrenheit, and I have a quality of 0.6. And I'm going to use those two values to calculate my volume. So I go into my table, and this is table A2E. Okay. Hopefully you can follow along in your book. You may not be able to see these numbers all that well. But, again, an A2E, this is my saturation table for water. Okay, I go down till I get to 260 degrees Fahrenheit, and I see that my saturated liquid and vapor volumes are given as 0.01708 and 11.77, respectively. Okay, so I know I'm 60% of the way between those two, which, you know, this is almost 0. This is, I don't know, I'm probably like 6.5 or something like that. But we'll go through and do the interpolation fully. So again, what we do for the interpolation, if I'm going to find this volume, this initial specific volume, okay, I will take that lower volume, which is given as so. That's the saturated liquid volume. And I'm going to take that and I'm going to add to it 60% of the distance between the liquid and vapor that I am, which is going to be the saturated liquid, or I'm sorry, saturated vapor minus the saturated liquid. Okay, so again, this is saturated liquid, and then this is 60% of the difference between saturated vapor and saturated liquid. So I'm 60% of the way between these two, and that gives me a volume of 7.07, and that will be cubic feet per pound. Now keep in mind, because this is a rigid tank, this also equals the final volume. Okay, so moving on, the content until the contents reach 320 degrees Fahrenheit. Okay, so I've increased my temperature. My volume remains constant, so I have temperature and I have volume. Okay, right, where again T2 equals 320 degrees Fahrenheit. So now, using this temperature, this volume, I'm going to find that final pressure. So I'll start back in that same table, 320, and I go to 320, and I notice that the volume for saturated vapor is 4.919. Now my volume is at 7.07, which means I am beyond the saturation point. I'm beyond that vapor dome, which means I'm in a superheated vapor, which means I have to go over to the superheated vapor table, A4. Now I'm going to go to a temperature of 320 and a volume of 7.07. Now you see in a lot of these tables I don't have 320. I have 300 and 350, so I'll probably have to do some interpolation, but I'm looking for volumes in the 70. Oh, that's not volume. This is volume. Volumes in the 7.07 range, and I'm too high at this point. So I slide over. Okay, and there, I'm not in between those two. Here we go. But okay. So here's where I am. I'm going to have to do a double interpolation here. So at 60 psi and 80 psi, you can see that between 300, at 320, this is going to be 7.4 or something like that. and then between saturation, which for 80 degrees is 312, I have a volume in between there. Oh, I don't know. That's going to be at 320. I don't know. 5.5. So you can see I'm somewhere between 7.5 and 5.5, which is where I am. I'm at 7.07. So unfortunately, I have to do a double interpolation, which is more than we typically would have to do on our problems. But in order to show you this interpolation, I want to show you this. So what I'm going to do first is find what my volume is at 60 psi and 320. Then I'm going to do 80 psi and 320. Okay, so at 60, okay, I'm going to interpolate between 300 and 350 to find this volume. Okay, so let's go ahead and do that. Okay, so for a pressure of 60 psi, and again a temperature of 320, I can do basically set up my slopes here, which is going to be 350 minus 300. That's what's in the table. And then I use my volumes, which are going to be 7.82 from the table and 7.26 from the table. And from that, I'm going to compare it to what's going on, use my 320 to figure out what it actually is. So I say 320 minus 300 times, I'll call it volume at 60 psi, use that, minus 7.26. So from this relationship, I solve for the volume at 60 psi, and I find the volume at 60 psi to be 7.484. Now I'll do the same thing at P equals 80 psi. Now this time, remember in this equation, okay, I have the saturation, right, instead of 300. So the lower temperature is actually 312.1 and 350, and then my volumes are 5.47 and 5.8. Okay, so I still have 350, but instead of the 300, it's 312.1. Okay, and then the volumes associated with those are 5.8 and 5.47. Then I set that up with my actual temperature, which again is 320 minus 312.1 all over. Then I want the volume associated with that 320 at 80 psi minus 5.47. So I set up my slopes, my equivalent triangles or similar triangles, and I can calculate V80 equal to 5.54. So now I have the volumes at 60 and 80 psi at 320 degrees Fahrenheit. So now I'm going to interpolate between these two values, because again I'm at 7.07, so I'm in between these two to figure out exactly what pressure I am at right here. Okay, so again I set things up and I say, okay, we'll use, these are essentially my table values here. So I say, okay, 7.484 minus 5.54. Okay, that's basically that difference. And then 60 minus 80. And again, these two line up. These two are associated with each other. Okay. Then I find my actual pressure, which will be, again, I'll just do 60 minus the pressure that I'm looking for here. Okay. And then that'll be 7.484 minus my actual volume that I'm looking for, because again I'm looking for the pressure at this volume and this temperature. So I put in 7.07. So again, these are my table values, or my interpolated table values, and then again the 60 and the 7.4 line up, and then my pressure with the actual volume that I'm using. Then from this interpolation, I can find that the pressure is actually 64.3, and that's going to be pounds per square inch, or PSI. Okay, so that's how we do interpolations. Okay, moving forward, I won't go the full-blown method like this, so you'll want to be comfortable with this because you will do this again hundreds of times this semester.